Hello there, welcome to the October 2020 paper 2. Here we're looking at question 5. So in this question here it says y equals tan inverse of x. Assuming the derivative of tan, prove dy by dx equals 1 over 1 plus x squared. Okay then, so we'll start with y equals tan inverse of x. And we'll start by doing tan to both sides. So tan of both sides will give us tan y equals x. Now we'll do a bit of implicit differentiation. So we're going to differentiate with respect to x, but when you differentiate a y function with respect to x, you differentiate it normally, so sec squared, but then you multiply it by dy by dx. And then when you differentiate 1 by dx, you get 1. So the answer here is going to be dy by dx equals 1 over sec squared y. Now remember, so recall that there is an identity that links sine and tan together. It goes tan squared y plus 1 equals sec squared y. So therefore, given that tan y is equal to x, x squared plus 1 will equal sec squared y. So therefore, dy by dx is equal to 1 over x squared plus 1. So there we are, that's the answer to part A. Let's now move on to part B. F of x equals x tan inverse 4x. Show that the integral of f of x equals this expression here. So what we're going to be doing here is integrating x tan inverse 4x dx. So we're going to be doing integration by parts. We're going to be setting this equal to the thing we're going to differentiate and this thing equal to the thing we're going to integrate, because we've just proven how to differentiate tan inverse 4x, so we may as well use that. So this is going to equal u, which is tan inverse 4x, v, which is half x squared, minus the integral of this thing differentiated. Now given that it was a 4, it's probably going to be 4 over 1 plus 4x squared from that differential from before. So it's going to be 4 over 1 plus 16x squared multiplied by the integral of x, which would be a half x squared dx. Okay, so let's sort out this integral then. Let's simplify it. It's going to be a half x squared tan inverse 4x minus, now it's going to be 4 over 2 is 2, but in fact what I'm going to do, I'm going to be sneaky and turn it into 16x squared on the top. So I'm going to divide by 8 at the front and call it the integral of 16x squared over 1 plus 16x squared dx. Okay, so hopefully that makes sense then, because we've got the 4 divided by 2 will give us 2, so 16 over 8 does equal 2, but now I've got the 16 on the top and the bottom. And now what I'm going to do is I'm going to be very sneaky. I'm going to add 1 and minus 1 on top of the integral here. And now I'm going to split them into two fractions. I'm going to split them into the one where we've got 16x squared plus 1 over 1 plus 16x squared, and then the second fraction, which is 1 minus, so minus 1 over 1 plus 16x squared. Let's get rid of those circle lines there. Okay, so let's do that then. Let's split it up like that. So it's going to be half x squared tan inverse 4x minus 1 over 8 times the integral of 16x squared plus 1 over 1 plus 16x squared is 1 minus 1 over 1 plus 16x squared dx. Okay, so now let's separate those two expressions into separate integrals. So it's going to be a half x squared tan inverse 4x minus the integral of 1 over 8 times the integral of 1 dx, and then plus, because we'll have a double negative here, plus plus 1 over 8 times the integral of 1 over 1 plus 16x squared dx. Now, from the formula booklet, what we have is an integral for 1 over a squared plus x squared, which is equal to 1 over a tan inverse x over a. So what we want to do now is move this 16 to the front here. So what I'm going to be doing here is I'm going to be dividing top and bottom by 16 on this integral. So it's going to become, so let's write this all out then, half x squared tan inverse x minus, now I know this integral here, that's going to be minus 1 over 8x. And then the next part is going to be equal to plus 1 over 8 times the integral of, now I'm going to be dividing top and bottom by 16 here. If I divide by 16 on the top, then that 1 over 16 will move to the front. It would be the 1 over 8 times the 1 over 16, which would be on the top, so that would be 1 over 128, and then it would be 1 over 16 plus x squared dx. So I've divided top and bottom by 16. Now that would be 1 over 16 on the top here, but I've factorised that to the front with the 1 over 8. So it's 1 over 8 times 1 over 16, which is 1 over 128, and then we've got this expression here. So now I've clearly got my a value as 1 over 16, or my a squared value as 1 over 16. So now I can apply that integral, the standard integral from the formula booklet. Oh, sorry, this is 4x. Did I drop the 4x at some point? Yeah. Then it'll be minus 1 over 8x, and then it will be 128, 1 over 128, and then the integral of this thing here, given that a is representing 1 over 4, is going to be 1 over 4, so that will be 4 tan inverse, and then it would be x over a, but a is 1 over 4, so it would be 4x on the integral there. Let's just now tidy up this final answer. Oh, we've got to do the plus c as well. So it's therefore going to be half x squared tan inverse 4x minus 1 over 8x plus, now 4 over 28, 4 over 128 is 1 over 32. So 1 over 32 tan inverse 4x plus c. And there we are. Whew, that is the answer to this question here. So A, B, and C. So A is half, B is minus 1/8, and C is 1 over 32. Right, so there we are. That's the answer to that part B. Then moving now on to part C. Hence, find in exact form the mean value of the function f of x over the integral from 0 to root 3 over 4. Okay, so what we're now going to do then is we're going to integrate from root 3 over 4 down to 0 of f of x dx. Now we've got the answer for that. That's going to be a half x squared tan inverse of 4x minus, and then the next bit is minus 1 over 8x, and then it's plus 1 over 32 tan inverse 4x between root 3 over 4 and 0. Oh, but it's the mean value. So what you have to do with the mean values, you have to do 1 over the difference between your intervals. So it's 1 over root 3 over 4. Or in other words, 4 over root 3. Okay, so let's now work that out. So substituting in is it 3? No, that's fine. So it's going to be substituting in the top value first. So it's going to be a half times 3/16. And then tan inverse of root 3, but we cancel out the 4's there. So tan inverse root 3 gives us pi by 3. Then it would be minus 1/8 times root 3/4. Then it would be plus 1/32 tan inverse of root 3/4 times 4, so that would be again pi by 3. And so we do that part, we've substituted in the upper boundary, now we'll substitute in the lower boundary, but I think that will give us a 0, that bit there will give us a 0, and tan inverse of 0, I'm pretty sure is 0 as well. Tan inverse 0, tan inverse 0 is 0 as well, so there's nothing for the last boundary being substituted in. So let's now simplify what we've got here. We've got 4/√3. And let's group the pi's together, this pi here and this pi here. So that 3 will cancel out top and bottom there. So it's pi/32, so 1/32. And then we will add that on to 1/32 times 3, which is 1/24. So it's pi by 24 minus root 3/8 times 4 is 32. So let's expand the brackets now. So it's going to be 4 will cancel out there and there to leave us 6. Oh, but hold on, the 4 won't cancel out the whole thing. So it'll be pi/√3 times 6. Whoops, that's slightly in the wrong place. pi/6√3. And then moving on to the next part, it's going to be the root 3's cancelling out, and the 4 will cancel out down there, so that would be 16/8, so it would be minus 1/8. So therefore this is going to be root 3 pi/18 minus 1/8. And there we are, that's the answer for this question 5 here. So yeah, so that's 10 marks in total there for question 5. Let's now move on to question 6.